In this video, we review the concept of complex numbers. A complex number z can be represented in a rectangular form, z equals to x plus jy, and j, that's imaginary unit, that's square root of -1. X is the real part, and y is the imaginary part. So let's look at the rectangular representation of z. Z here is a number. Remember, z is a number, and the x-axis is real part, the y-axis is imaginary part. Z equals to x plus gy. That's x is a number, and y is here. This portion is y, and y is also a number. So this is a rectangular expression for complex number. Complex number can also be represented by other format. One is polar form, the other one is exponential form. So this is a polar form. It can be represented by the magnitude r and the angle phi. In this case, the magnitude of z is r, the angle is phi. The direction of phi is counterclockwise. So this is in phi. The complex exponential expression is r e to the power j of phi. This is a complex exponential expression. We have Euler's formula here. E to the power j phi equals to cosine phi plus j sine phi. That equals r cosine phi plus j sine phi. Okay. Relate this expression and this expressions, they are all equivalent. X will equals to r cosine phi and y equals r sine phi. This is exactly we can relate in the graph. X, this is a x equals to r cosine phi, and y equals to r multiplied by sine phi. They're from the triangular formula. So this is the expression for complex numbers. Three format. One is rectangular expression, the other one is a polar form, the other one is exponential expression. If we know the value of x and the value of y, the magnitude of this complex number z equals square root of x squared plus y squared. And the angle we can calculate by arctangent of ratio of y divided by x. When we apply the arctangent function to obtain the angle phi, pay attention to where the complex number is. So for example, if z equals to -2 minus 3j, then z is in the third quadrant. So the phi here is phi is greater than 180 degrees in the third quadrant. But if we look at this function directly, if we just look at this function directly, that will be -3 divided by this will be less than 90 degrees if we plug in this function directly into your calculator or things like that. Again, we know x equals r cosine phi and y equals sine phi. Let's look at the operations between complex numbers. Addition, real part plus real part, imaginary plus imaginary part. And subtraction, you subtract the real part and imaginary part. Multiplication is easier to express in the polar form. So magnitude multiplied together, the angle plus angle take the summation. And if we do division, the magnitude take the division and the angle take the difference. For reciprocal, the magnitude take a reciprocal the angle is reversed. Phi becomes minus phi. If we take square root, you take the square root of magnitude, the angle, you take half of the angle. Complex conjugate, z original equals to x plus jy. Then z conjugate equals x minus jy. If using polar form, the magnitude does not change, the angle reverse, become negative. So this is complex exponential expression r e to the power minus j phi now. Now let's look at example. I have one complex number x1 equals 5 plus j2 and x2 equals minus 1 plus j4. So if I want to have addition of x1 and x2, so y1 equals to x1 plus x2, so real part plus real part, that's 4, and imaginary part plus imaginary part, that's j6. If I want to take the difference of x1 and x2, so y2 equals x1 minus x2. So the real part takes difference, that's 6. The imaginary part takes the difference, that's minus j2. So now let's look at the product multiplication of x1 and x2. And here I'm going to use handwriting here instead of typing. It's probably a little easier. So y3 equals to x1 multiplied by x2. There are actually several methods. One method is just we can perform the multiplication using the rectangular form, or we can use polar form to perform the multiplication. We will demonstrate both. Let's look at the rectangular form first. So x1 5 plus j2 multiplied by minus 1 plus j4. This multiplication is just do item by item, the item by item multiplication to break this bracket up. 5 multiplied by minus 1, so minus 1, and plus this j2 multiplied by minus 1, that's minus 2j. And then this 5 multiplied by j4, that equals j20. And this plus j squared multiplied by 8. And we know j squared equals to minus 1. Plug it in and then do a little reorganization here. J and j, that equals to 18j and then minus 8. And then you combine this together. Real part, this minus 13 and plus 18j. These are rectangular form. And also we can look at from the graph, real part and imaginary part graph. So this is real part, this is the imaginary part. x1, the real part is 5, the imaginary part is 2. This is x1, and this is a magnitude r1, and this should be phi1. Okay, and x2, real part minus 1, and j4 is somewhere here. So this will be x2 here, and this is where x2 is. Next, let's illustrate how do we obtain the polar form from the rectangular form. To obtain the polar form, first of all, we need the magnitude. The magnitude is the square root of the real part squared and the imaginary part squared. So that will be 5 squared plus 2 squared, and take the square root. And next, that's the angle. The angle we will obtain using the MATLAB, the command angle. And MATLAB ABS calculate the absolute value of the complex number will give us this number. We can calculate by calculator ourselves, take the square root, or we can use ABS at the MATLAB. Pay attention, the unit of the MATLAB give us the radians if we use the angle command. To convert from radians to degree, we take this command, we take this number, you multiply by 360 degree and divide by 2 pi. That will give us degree. Next, let's illustrate the MATLAB command. x1 equals to 5 plus 2j. So in MATLAB, j and I are the same thing. It's unit of the imaginary part. In MATLAB, if we do not define j or I, MATLAB define j and I by square root minus 1 by default. x1 equals to 5 plus 2i. Let's see if we have ABS x1, that gave us 5.3852. If we can check to see if it is a square root of the real part squared and the imaginary part squared, to see if they're the same or not. That's the same. And then let's look at the angle. The angle x1, that's 0.3805. Remember, this is radians. To convert the radians into degree, we're going to have this multiplied by 360 divided by 2 and pi. So 21.8 degree. Now the polar form can be written at 5.4, the angle 21.8 degree. So remember, here that's the unit of degree here. To express this complex number using the exponential form, that equals to 5.4, that's the magnitude, and e to the power j, 21.8 degree here. So basically, that's the format of r e to the power j of phi. This is complex exponential format. This is the polar format. And this is rectangular format. So there are 3 formats we can express a complex number. They can interchange with each other.